Welcome to all of you in Sanskar Global's online classes. As we are going to start today a new topic of class 11 physics, which is chapter 3, laws of motion. So in this video we will discuss about laws of motion. What is laws of motion? So before we discuss about laws of motion, first we deal with some basic concepts which are related with laws of motion, that is about force, about inertia, and what is momentum. So these are the basic terms which are used in laws of motion. So the first term which we use generally in our daily life is force. What is force? How we define the force? So force is a external effort. For example, when we try to push a cart, which is placed over the surface of the earth, or when we try to pull a ball, then these are the effort which we apply. For example, if there is a chair and we want to slide it, then we apply a force. That means the effort which we provide to the chair is known as force. So force is a external effort in form of push or pull. That is known as force. And what is linear momentum? So here in this topics, first we discuss in brief what is force, what is linear momentum, what is inertia, and then after in details. So linear momentum is the measure of motion in a body. That means the quantity of motion present in the body is known as linear momentum, and to evaluate the value of linear momentum, we generally multiply mass into velocity. And in case of so this was the linear momentum, and now we move to the inertia. So inertia is the fundamental property of a matter, by virtue of which it opposes any change in its state. It means if objects are in rest, then it remains in rest, and if objects are in uniform motion, then it remains in uniform motion because of inertia. Okay, so these were the basic terms. Now we move to the today's topic, which is about laws of motion. So in case of laws of motion, there was an initial theories, there was a history of law. So the first philosopher which comes in mechanics, which comes in physics, described the laws of motion was Aristotle. So according to Aristotle, if we want to make uniform motion, that means if we want a body moves uniformly, then we need some external effort, and that external effort is known as force. So according to Aristotle and his followers, there was a belief that if we want to uniform motion, that means if we want a body moves continuously with uniform velocity, then we need some external effort, and then we need some external force. So for uniform motion, it is essential to have external force or external effort. According to Aristotle, that was done, and which was proven wrong by Galileo later. So according to Galileo proved that there is no need of external force of uniform motion. According to Galileo, rest and uniform motion both are equivalent to each other. It means the Galileo's statement or the Galileo's point of view was different to the Aristotle's. So according to Aristotle, for uniform motion, external force is required, and according to Galileo, for uniform motion, there is no requirement of external force. Okay, now we move to the next one. So later, Newton came into the mechanics, came into the physics, and gave three fundamental laws of motion. So today here we are going to discuss about Newton's first law of motion, or simply it is known as law of inertia. So Newton's first law of motion or law of inertia, both are the same rules. So according to this rule, if a body continues to be in its state of rest or state of uniform motion along the straight line until and unless an external unbalanced force is applied over it. It means a body which are in rest position, will not move, will not change its state until and unless we apply an external unbalanced force. Here, if we apply external force, then that doesn't mean the body will move. Our external force must be unbalanced, then its state will be same. So it means if we apply external unbalanced force to an object, then its state changes. If we do not apply external unbalanced force, then position or the state of the object do not change. It means a body which are in rest will remain in rest, and a body which are in uniform motion along the straight line will remain in uniform motion as long as we are not applying external force. So it is essential to change the position of an object or to change the state of an object. External agency is required. So it means if you want to change state of any object, then there must be applying some external effort, and that external effort is known as force. So the first law of motion provides us the concept of force, and so the law of inertia, that is the concept of inertia. Both the concept of force and inertia comes from first law of motion. So according to first law of motion, it is simple that a body which are resting, which are in rest, are not going in motion because of its inertia. Why the body which are in rest remains in rest? Because the body has some mass, the body has certain mass, and mass have a property which is known as inertia and which opposes any change of its state. So inertia comes from Newton's first law of motion, and also the concept of force also comes from law of motion. So it means when I want to change the state of an object, then we apply some external unbalanced force. So force is required to change the state of a body. So it means force, the concept of force and the concept of inertia come from first law of motion. Okay. So according to this law, any body continues to be in its state of rest or in its state of its uniform motion until and unless we are not applying unbalanced external force. So it means rest and uniform motion both are equivalent in the position, that means the state of rest and the state of uniform motion both are equivalent and in both cases acceleration is zero. Okay, now we move to the inertia. So inertia, so here we discuss about inertia. So inertia is the inherent property, that means inertia is the fundamental or intrinsic property of a material, of a matter, by virtue of which it opposes any change in its state. It means any body which are moving in a straight line with uniformly do not want to change its state. That means it always want to remain in uniform motion. And if we want to stop this uniform motion, then we have to apply some external force. Similarly, if an object which are in rest always remains in rest until we are not applying an external force. So here the term inertia means this is the property which comes in the matter because of its masses. Inertia is basically divided into three parts: inertia of rest, inertia of motion, and inertia of direction. So inertia of rest means a body cannot change its state of rest. A body cannot change its state of uniform motion. Similarly, a body cannot change its direction of motion because of the inertia. So the inability of a body that it cannot change its state of rest by own self is known as inertia of rest. And similarly, the inability of a body that it cannot change its state of uniform motion is known as inertia of motion. And similarly, inertia of direction means the inability of a body that it cannot change its direction of motion by own self is known as inertia of motion. For some example, if we are just imagine if we are standing in a bus and the driver starts the bus suddenly, then our lower part of the body moves to the bus along with the bus, but the upper part of the body remains in rest because of the inertia, and that's why our body leans backward. And so this is just because of inertia of rest. Similarly, if we go to the other example, if we are shaking a branch of mango tree, then in that case the fruits of the mangoes falls down because of the inertia. Because when we shake the branch of mango tree, then in that case branch comes into the motion while due to of the inertia, mango's fruits are in rest, and therefore there must be some displacement between branch and fruits, and that's why fruits falls down. And if we are rounding a turn and sitting in a bus, then we generally feels that while rounding the bus, our body moves in the opposite direction of the turning because of the inertia of direction. Okay, now we move to the linear momentum. What is linear momentum? So linear momentum is the quantity of motion, or we can say that the measure of quantity of motion in an object, and it is equal to the product of mass and velocity. That means if an object are moving with certain velocity and certain mass, then the product of mass and velocity will be equal to the linear momentum of the body. And linear momentum is a vector quantity, and its direction is always towards the direction of velocity. It means linear momentum always acts in that direction in which the object are moving, or we can say that in which the direction of velocity. For example, we know that there are two objects, or if we consider that there is a truck and there is a car, and we have to move both truck and car, then we realize that to move car is easy, in case of truck, while to move truck is difficult compared than the car, because there is a change in both the object. Car has lesser mass while truck has greater mass than the car. So it means if we want to apply force, then the force will depend on the mass of the object. It is very simple that if we want to stop two balls, the one is heavier and the one is lighter, then what we realize is that to stop heavier masses, we need to apply greater force. While if we want to stop a lighter object, then we need lesser force applied over the object. So it means the force which we apply over an object depends on the masses of the object. Similarly, if two objects are moving with different velocities, then to stop the object which has lower velocity is easy in case of the object which are moving with greater velocity. So if two bodies which are moving with different speeds, then the force applied over the object depends on the speed of the object, and that's why the product of these two is known as linear momentum. So it means the force which we applied over an object depends on two factors, mass and velocity, or we can say one word, that is force depends on linear momentum. So P is equal to mv. Here the unit of linear momentum is kg per second and dimension is ml/t-1. When we plot a graph between linear momentum and velocity, keeping mass constant, then we get that while applying the velocity, when we increase the value of velocity, linear momentum increases. When we decrease the value of velocity, momentum also decreases. So it means momentum and velocity both are directly proportional. Similarly, if velocity is constant and mass is changing, so it means when we increase the mass, momentum also increases. It means momentum and mass is also directly proportional. And if P is constant, that means if momentum of a body is constant, then it means velocity and mass will be inversely proportional. If mass is increases, then velocity will be decreases, or if mass is decreasing, velocity will be increasing. So that was the today's topic, which is about inertia or laws of motion. Now in our next video, we will discuss about Newton's second law of motion. Thank you.